So moving on from these early surveying and data collection methods, as time progressed and as societies advanced a little bit and became slightly more interconnected, trade and travel expanded our conceptualizations of what the world was. And so as we had more information, we had to compile that information into collections and build bigger and bigger maps and build on that knowledge. So, for instance, the Greeks built on the knowledge of the Egyptians and Mesopotamians and came up with a conceptualization of what their world was, which was essentially the Mediterranean basin and the lands around it. And so here is an example of one of the earliest world maps from Greece, about 2,500 years ago. You can see they roughly group it into Europe and Asia. And so it's pretty accurate representation of what things actually look like around the Mediterranean. The farther away from you get from that, the less they knew about those parts of the world. And so as things advanced a little bit more and we got more and more information, maps became bigger and bigger and more detailed and more accurate. The first atlas appeared. So there's, from 1,850 years ago, Ptolemy's Geographia is the first ever, at least first surviving example of an atlas. And so this is essentially an 8-volume GIS prototype. So there was a series of 8 maps and one large world map. The atlas had an index of place names, so you could look up specific places and find their location on the map. And it was even one of the first maps to use a projection to represent the world. So you can actually see the curvature of the Earth in this map. Now, it wasn't necessarily an accurate map. It underestimated the size of things. But it's pretty cool to see the conceptualization of the world they had. So you can see, again, the information around the Mediterranean basin is fairly accurate, and the farther away you get in any direction, the less accurate things look. So, for instance, this is what they thought India looked like. Here is the Indus River and the Ganges River. And for some reason, Sri Lanka is huge relative to the Indian subcontinent, which is obviously not correct. But if you think back to the tools that these people had, the way that information was conveyed during these times, it's really, impressive. But again, it wasn't just the Greeks and the Romans who were doing this. Chinese exploration also played a big part in sort of learning about the world and discovering things. So the Chinese made numerous advances in maritime technology, specifically the compass and then ship design. So they mapped most of South and East Asia, East Africa, Indonesia, and Australia. And so actually before the Europeans started exploring the world, there was a period of exploration and expansion that occurred in China where they mapped out very large swaths of area. There's even some evidence to suggest that they made it all the way to the west coast of North America, although there's no verifiable evidence of that yet. Another example, one of the first world maps to appear, compiling more and more information. This one has most of Europe, Africa, and Asia on it. So this was before verifiable records of the Americas were available to Europeans, but they had records of at least most of the Eastern Hemisphere. So this is one of the first world maps to appear. I think it's really cool. It shows south as up, so they had the map sort of pointing towards, the direction the sun was in the sky from the Northern Hemisphere perspective. So starting in the late 1400s and early 1500s, we had the Age of Discovery, which I don't think is a very good name because Europeans didn't really discover anything. They just stumbled on places that were already inhabited. But that said, that's how it's typically referred to in history books and stuff. Basically, we had two competing empires, the Portuguese and the Spanish, who were expanding across the world, competing with each other. And so around this time, the first verifiable circumnavigation of the planet was conducted. So it was verifiable that the Earth was round, even though, again, most people already knew that. Even though perhaps the dominant European culture at the time thought the Earth was flat, there was a lot of evidence to suggest that it was round for, hundreds of thousands of years before that. But with this age of discovery and European expansion, European perspectives came to dominate the cartographic world. So once, we sort of traveled around the whole planet and there was a lot of maritime navigation occurring, map projections became a necessary reality. If you want to use a map to navigate, it's important for the map to be accurate. So in the mid-1500s, the first sort of mathematically rooted map projections became available. Specifically, one we still use today is called the Mercator projection. And so this map projection revolutionized mapping and navigation. There are a lot of issues with this map projection, and I will talk about some of them in future parts. Later on in the week, we're going to talk about map projections, for instance. But one of the things that it is great for is navigation. You can follow a constant bearing on this map, and you will end up where that line says you will end up. So if you're trying to sail across the ocean, you can set your compass bearing to a specific angle, follow that line, and you will end up where it says you're going. It's not the shortest distance to get to any point, but it'll get you there. So one of the key issues with the Mercator projection is that it severely distorts areas near the poles. The closer to the poles you get, the larger things look. If you look at a Mercator projection, northern Canada and Greenland look gigantic. Mexico and Africa look fairly small. And so this is problematic because size is often equated with importance. And so when you have a large overrepresentation of the size of, say, England, it makes northern countries look more important than they actually are. And I'll talk more about that later. So as we got more geographic information and as our sort of understanding of mathematics and statistics became more well-rounded, maps began to move beyond just navigation and reference, and we started to develop spatial analysis methods. So I'm not going to go into too much detail on this now, but spatial analysis is a key part of GIS, so I'll talk about it quite a bit later. But spatial analysis drew from various fields, so epidemiology. For instance, we're actually going to do this example in lab. John Snow was an epidemiologist who used geographic data to solve a problem. One of the first recorded examples of this. So again, taking maps beyond just navigation. But it also drew from biology, statistics, mathematics, just to name a few. So the example that we're going to do is a foundational study in epidemiology where Dr. John Snow used a map to record the locations of deaths from a cholera outbreak in London and used that to identify the point source of that cholera outbreak. So it's a pretty revolutionary study. We're going to recreate it in a GIS and create a map that looks something like this for lab this week. So shifting over, while Dr. Snow was investigating cholera outbreaks in London, at the same time in Canada, the Geologic Survey of Canada was formed. So it was founded in 1849. And it's Canada's first scientific agency. It was tasked with mapping mineral deposits, and essentially the main goal was to promote economic expansion across Canada. So the Geologic Survey went all across Canada, mapped out the landscape, mapped out the mineral deposits, essentially with the goal of identifying the most valuable lands. Building on that, as the century progressed and technology advanced and the railroad became a thing, Canada decided it was time to build a railroad across the country. And so they used the information that was collected by the Geologic Survey to determine a path for the Canadian Pacific Railway. And so building on these surveys, Canadian Pacific was granted 25 million acres of valuable land on either side of the railway path. And then they sold it at $2.50 an acre to European colonists. And so this resulted in the displacement of First Nations peoples across the prairies and Western Canada. So with all that information that was collected by the Canadian Geologic Survey and various other organizations to follow, this led to something called the Canada Land Inventory. It was essentially a large repository of mapped information. The goal of this project was to map the suitability of all the lands in the country south of the tree line and map their suitability for agriculture, forestry, recreation, and wildlife. And so this project started in the late 50s, early 60s, and it generated a very large amount of information, so much so that it was very ineffective to store it just in paper map format. So they had to develop a new system to sort of catalog and inventory all that information. And so this actually led to the creation of the first geographic information system called the Canada Land Inventory. And you can actually still access all these maps online. So this was the first geographic database. They put all of this information into a computer, stored it on a server, and could use geographic information systems to interact with this spatial data. It allowed for much more efficient and effective use of information than just having to reference paper maps constantly. And then GIS expanded and proliferated from that. So as technology developed, I think the land inventory GIS was finalized in 1969. After that, technological development, so improvements in hardware, led to the proliferation of GIS software. The software began to become available commercially in the 80s, which significantly expanded the user base. And more recently, open source, so that's free, open access GIS, and web-based GIS have begun to proliferate. And so I'll talk later on in the term about open source GIS. I'm a big proponent of it myself. There are advantages to using proprietary software like Arc Pro. It's easier for introduction to novice users, for instance. But at the end of the day, I think that the free open software packages are oftentimes better.